So in this video, we're going to talk about the area under the curve, or essentially the integration, right? So this is how a graph of this function looks like, right? Uh, and by the way, just to point out, these are graphs that you might not need to know. You just need to know how to do the integration, or essentially find the area under the curve, right? So I'm going to take a look at this, and the first thing I'm going to do is rewrite my integration. I'm going to bring the square, I'm going to rewrite them as powers, everything in terms of powers, right? So I'm going to say this is integration of x to the negative 1/2, since this is the square root of x, right? Square root of x is just x to the 1/2, but because I'm bringing it to a different spot, alternating from the denominator to the numerator, I have to have that negative there, right? And this will be 1 plus the square root of x raised to the 1/3 dx. All right, now I'm looking for u substitution. All right, so what can I set as my u in order to get something that makes sense? Well, I see that this is x raised to the 1/2, right? So I'm thinking that, okay, well, if I take the derivative of this, I might get something that I already have. So let's see. If u is equal to 1 plus x to the 1/2, right? Because square root of x is just x to the 1/2. Then my du, or the derivative, well, bringing the 1/2 down, x taking 1 away from that, that's just negative 1/2. Right? Now I have a negative 1/2 here. I do not have 1/2, but that's okay. I can multiply by 2 on the other side to get rid of this 1/2 here. All right. So if I multiply by 2, then 2 du becomes x to the negative 1/2 dx. And sorry about that. This dx should be attached here. All right. So now we set up our function for perfect u substitution. So rewriting the integral, this is just u to the 1/3, right? Because we said this was our u. Du, 2 du, right? 2 du takes care of this x to the negative 1/2 dx, right? Or this du takes care of x to the negative 1/2 dx. This is our u to the 1/3. Now this becomes a simple integration problem. So we're gonna add 1, right? So this now becomes u. This now becomes u to the 4/3 plus 1. And because I don't want to have complex fractions, I'm just going to multiply by the reciprocal. So this now becomes 3/4. But remember, we have a 2 here, so that's also going to be multiplied. All right, and don't forget we're dealing with the indefinite integral, so that will be plus c. Now I could cancel out. I have a 2 here, I have a 4 here, so this becomes 2. All right, so rewriting the whole integral, we get 3/2, 1 plus the square root of x, which is our initial u, plugging in back for u, to the 4/3 plus c. And that will be our area under the curve. Let's look at a simple, more simpler one. So we have the square root of 7x minus 1 dx. All right. Again, this is simply u substitution. So I could set my u to be equal to 7x minus 1, right, where my derivative will be just 7. My derivative will be 7 dx, right? So my derivative is 7 dx. Well, I have 1 dx here. So if I divide by 7 on both sides, then 1/7 du will be dx, which is exactly what we have here. So rewriting the integral, this whole thing under my square root is just u. So this will be u. Now remember, we're dealing with the square function, so this is actually this whole thing raised to the 1/2. So this is u to the 1/2. And then remember, we have our 1/7 du to replace our dx. Or u replaces our function under the square root with the power to 1/2. All right. So taking the integral now, well, 1 plus 1/2 is just u to the 3/2. Again, I'm going to multiply by the reciprocal because I don't want complex numbers. So this is just 2/3. Remember, we have a 1/7 outside here, so that's going to be multiplied. All right, and then we're dealing with the indefinite integral, which is just plus c. So putting everything together, this now becomes 3 times 7 is 21. So this becomes 2/21. Or u is actually 7x, or u is 7x minus 1. So this is 7x minus 1 raised to the 3/2 plus c. And that will be our integration. Again, so nothing hard. Let's look at one more. All right, and we have this one here where we have x squared plus 5 to the negative 4 dx. How are we going to integrate this? Well, again, I see that I have an x outside here, right? If I take the derivative of this, well, I could see that I'm going to get a 2x. I don't have a 2x, but that's fine. We could fix numbers. We just can't fix the x's, all right? So if I set u to be my x squared plus 5, then du will be 2x dx. All right. Now, again, I have one x here out here. I don't have a 2. So 1/2, if I divide by 2 on both sides, then 1/2 du will be x dx. So we're going to substitute 1/2 du for x dx. So rewrite an integral. This now becomes u to the negative 4. 1/2 du replaces x dx. And this is our u to the negative 4. All right. So taking the integral, this now becomes u to the negative 3, right? Because we're adding 1. Divide by negative 3. Remember, we have 1/2 that's being multiplied out here. And we're dealing with indefinite, so this is plus c. So factoring everything out, this becomes negative 1/6. Or u is initially x squared plus 5 raised to the negative 3 power plus c. And that will give us our answer. So this is just simply area under the curve.